let's do number 8. Which is the strut problem. Which, yeah, like I said, it seems very similar, but there is one significant difference. All right, so here's the setup. So you've got, attached to the ground, you've got a little hinge, and coming out of the hinge is this strut, which again is a silly word for a bar. I don't know why the book seems so fascinated with using the word strut. So one of the differences, it doesn't tell you the length of the strut. So let's just call it L. Okay? It does, however, tell us that it makes a 45-degree angle with the horizontal. Okay? Now, hanging from the top of the strut, you've got this mass that's 225 kilograms. And so the force from the weight, I'm going to use W there, the force of the weight of that mass turns out to be 2,205 newtons. Is that right? Yeah, that's right. Okay. All right, so that's just 25 times, it's 22.5, isn't it? No, it's 225. Sorry. Numbers are right. I just can't talk. So this is 225 times 9.8. Cool? Sorry about that. All right. Let's see. What else do we know? It tells us the weight of the mass of the strut itself is 45 kilograms. So I'm going to put a little X here at the center. The force of gravity acting on the strut itself is 45 times 9.8, so that's 441 newtons. Everybody good? All right, and so finally, right now, everything is trying to make the strut kind of like tip over, right? So they take a string or a cable or something, and they run it all the way over to here, and that tension pulls this way, and this angle down here is 30 degrees. Cool? So I don't know if it makes sense to do this. And you know what? I am going to do it. Do I want to do this? I don't. So you could, if you wanted to, split that force up into components. How do you know that you don't want to do that? Let me hold that thought for a minute, and I'll show you in a minute why I am deciding not to split that up into components. Okay. You could split it up into components, but I think it makes it a little bit harder. All right. Are there any other forces? Yeah, the thing at the bottom, this little hinge is doing something, right? So let's see. Right now, all of my forces, vertically, all of my forces are down now, right? So there's got to be an upwards force from the hinge, right? Oh no, I'm out of colors. I'm going to reuse black, and you're just going to have to deal with it. So there's the force from the hinge vertically that's counteracting gravity, the weight, and the vertical component of the tension, right? What else does it have to be doing? It's got to be, which way is the tension pulling? Left, right? So the hinge needs to be pushing right to prevent the whole thing from sliding this way, right? So here's the force from the hinge in the x direction. Cool? Questions? Alrighty, so solve. So once you guys get a little bit more experience with this and practice a little bit more, hopefully you'll get to the point where you're gonna look at this and go, oh, I need to start with torque. Maybe that's not obvious for you right now, so let me show you why. All right, so my process has been, all right, let's start with this. Net force horizontally has got to be 0, right? Does that buy me anything? Really, all it tells me is that the force up from the hinge horizontally has got to be canceled out by the force of the tension horizontally, right? Follow? All right, let's see. Net force vertically is 0. Again, that doesn't buy me much either, right? Basically, that just tells me that the 4 vertical forces I have here have to cancel each other out, right? Why am I saying 4 vertical forces? Yeah, there's a vertical component to tension, gravity, and the weight all pull down, and the hinge has to cancel those all out, right? Follow or no? So I guess I don't know that I would write this out if I was actually solving the problem, but here's what we've got. The force from the hinge vertically has got to cancel out the force of gravity plus the force of the weight plus the vertical component of the tension. So what we've got is just a giant mess of unknowns, right? Follow? So we need to think about torque. So the net torque has got to be 0. All right, so if the net torque is in fact 0, which it is, we can say that around any pivot point. So at this point, we've got, depending on how you count, 3 or 4 unknown forces, right? The vertical component from the hinge, horizontal component from the hinge, and then the tension, right? So what do you want to choose as a pivot point? Yeah, let's choose the hinge, right? That's going to negate these 2 unknown forces, right? Cool. So let's choose this as our pivot point. Can I use P? I can. We're going to call this point P because we don't have a painter this time. So the net torque about point P has got to be 0. So here we go. The net torque about point P is, name the forces for me. What do we got? Torque from gravity plus the torque from the weight plus the torque from tension. This is why I didn't split that tension up into components, right? Because now I only need to worry about the one torque from the one force of tension. Whereas if you split up into components, then you'd have 2 unknown components and therefore 2 unknown torques. And things get a little bit ugly. Follow? Okay, so it's not wrong to do it, but it just makes it harder. Follow? Okay, so let's plug in our numbers. Net torque around our pivot point is 0. Equals, let's see, the torque from gravity. Oh shoot, what's my distance there? Half of L, right? So let's make a little note of that. This is L over 2. So L over 2 is my distance, times my force, times the sine of 45 degrees, right? And then once again, negative, right? Because that's going to make it go, it's trying to make it go clockwise. All right, we're almost done. Plus the torque from the weight. So L times 2205 times the sine of, again, 45 degrees. And again, negative. Follow? Finally, plus the torque from the tension. So how long is my lever arm for that tension force? L, because it's all the way at the end, right? Times my tension force, which is the thing I'm looking for, times the sine of Q. Yeah.
Wait, how come with the force of tension, how come it's L instead? Wouldn't it be longer? Because
I gotcha. So your lever arm is always the distance from your pivot point to where the force is being applied on your object. So here's my pivot point. The tension is affecting the rod up here. So it's that distance. So even though it's connected to the floor here, that doesn't matter.
Okay, gotcha.
So here's why this point is important. This point determines this angle, and therefore this angle.
Okay.
Follow?
Yeah.
All right. So times sine of some angle. Do you guys see which angle we want? Just this guy, right? I say just, like it's super easy to find, but good. All right, so we got to find a way to find this stupid angle here. So you got a geometry. So if you look at it worked 4th hour. All right. If you look at this triangle here, bounded by the floor, the bar, and the rope, don't those three angles need to add up to 180? What's this angle over here? 180 minus 45, right? So that's 135. So we got 135 plus 30 is 165. So this guy has to be 15 degrees. All right, so that's 15 degrees. And now the only variable we've got now is this tension and L. Ugh. It cancels. If you move everything that doesn't have FT into it on the other side, you get a bunch of L's equals L times this, and the L's cancel. Cool? Cool. So then when you find it, your tension force is 6,630, or I think it's 26 if you don't round. So there's your tension force. So then, now we split this up into components and set our net force is equal to 0. In other words, this is just the x component of the tension. Cool. And then the vertical component has to cancel the vertical component of the tension plus the two other downward forces. Questions, you guys? All right. Does that help a little bit, you guys? Make those drawings and then just systematically kind of go through your three equations and see what they buy you. If you get lucky, one of the force equations will help you. It's rare, but it's worth checking them first because if it helps a lot. You know what I mean? Questions on it? All right, so the last one I want to do then, I think the last one we probably have time for is the one about rolling the tire up this step. This is like, again, this is another like classic, oh, I'm going to stop recording.